Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 24 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2799. Count complete subarrays in an array. Okay, so this problem is actually very easy. I'm not going to say that it is so medium level, it is very easy. Okay, and I'm going to tell you total two approaches, okay, to solve this problem. One is going to be have time complexity of n square, and one is going to have time complexity of n. Okay, so first let's read the problem statement first. You are given an array nums consisting of positive integers. Okay, so nums array given to us consisting of positive integers. We call a subarray of an array complete if the following condition is satisfied. The number of distinct elements in the subarray is equal to the number of distinct elements in the whole array. Okay, so number of distinct elements in the subarray, it should be equal to the number of distinct elements in the whole array. Then we are going to say that particular subarray of an array is complete. Okay, we have to return the number of complete subarrays. A subarray is a contiguous non-empty part of an array. Okay, so let's see this example number one. Okay, so this is a nums array. Okay, so here see, if you see this here, we have distinct elements like 1, 3, 2. Okay, so total three distinct elements. Okay, three distinct elements are there. Now see these subarrays. Okay, so first is starting from this to this. Okay, so here also three distinct elements. Then see this 1 3 1 2 2 complete. Then also three distinct elements. Then 3 1 2, again three distinct elements. Then 3 1 2 2, again three distinct elements. Right. So these are the four valid complete subarrays. Okay, so 4 is output, right? And same way in example 2, nums is given to us this 5 5 5 5, and we have output as 10. Okay, so like if you use this 5 once, then you use 5 5. Okay, starting from here only, I am starting from here only, right? Okay, 5 5 5, then again 5 5. Okay, 4 5, then start from here. Okay, again 5, then 5 5, then 3 5s. Okay, then after that start from here. So one is 5 and then double 5. Okay, then after that start from here. So you have just single 5. So in total now calculate 1 2 3 4 5 6 7 8 9 10. So 10 is the output. Okay, the array consists only of the integer 5, so any subarray is complete. Okay, the number of subarrays that we can't use is 10. Okay, and see, constant size is very small. Nums dot length is 1 to 1000 only. Nums of I elements 1 to 2000 only. So definitely we are going to pass the solution in of n square time complexity as well. So first let's see how we are going to solve this question in of n square time complexity. Okay, so take this example number 1. Nums is equal to 1 3 1 2 2. Okay, 1 3 1 2 and again 2. Okay, so this is the num arrays, right? 1 3 1 2 2, right? Okay, so here what you need to do, first of all, just calculate the distinct elements in this. Okay, so just create one set, and in the set just add the distinct elements. So we have distinct elements like 1 2 and 3. Okay, so set only consists of unique elements, right? It doesn't contain duplicates, right? So that's why we are going to use set. Okay, so now after that just calculate the size of this. Okay, so 3 is the size. That simply means that 3 elements, okay, three distinct elements are there in my nums array. Okay, so this is going to be first step, okay, to solve this problem in O of n square time complexity. Okay, using brute force. Then what you need to do, place your I here. Okay, and create one more set. Okay, and in this set just add the elements side by side. Okay, so first create this new set. Okay, then start your j from here. Okay, so here see, this is a new window, right? New set. Okay, so here add one, it is empty. Okay, then move your j to the next index. So j moves here, then add this 3. Okay, then after that j moves here. Set consists of this one, so we don't need to add anything. Okay, and now after that j is going to move here. Okay, your I is fixed here only. Now j moves here, so here you are going to add 2. Okay, so now here if you see, this is having size 3 now. Okay, this side and this side both are matching. Okay, so that simply means that starting from this I and until this j, we have one complete subarray, right? Okay, so now what you need to do, you have to increment the count. Okay, so how I am going to increment the count? I'm going to increment the count like this. Okay, so let's suppose these are the indexes 0 1 2 3 4. Okay, so if this is a complete subarray, definitely this is also going to be complete subarray, right? So in the count, what I'm going to add, I'm going to add the size of my this nums array 5. Okay, minus the j. Last time j is at index 3. Okay, so I will add 2 in my count. Okay, so why am I writing 2? So if this is complete subarray starting from I to j, so definitely if I add other elements, okay, after this j, they are also going to form complete subarray only, right? See here, 1 3 1 2 is complete subarray. So after that I can add anything, so it is going to give me the complete subarray because I am adding the elements from this nums array only, right? So this is going to valid. Okay, so here that is why I am using this formula n minus j. Okay, this is going to add, this is what I'm going to add every time in my count. Okay, so existing value of count is 0, so in that I'm adding n minus j. Okay, done. Now once this is done, then after that you have to break your j loop. Okay, so break your j loop. Okay, so this is done. Now after this only you have to move I to the next position. So now you are going to move I here. Okay, and now again you have to empty this. Okay, complete. Okay, again you are going to use this new set. Okay, and now again you are going to move j here. So first j here you are going to add 3, then next time j is going to move to the next position. Okay, only j is what we are moving, right? So here 1 will come, then next time j is going to move to the next position. Okay, then 2 will come. Now again see here, this is also one valid window. Okay, complete subarray. So now in the count, previous count was 2, in this the n value total size is 5 minus 2. So this is what I'm going to do, 5 minus 2. So I will get 2 plus 2 4. Okay, so count becomes 4. Okay, then again we have to break this j. Okay, now we don't need to execute it further. Okay, because we have found one complete subarray. Now you have to move I next position. Okay, so now I moves here. So again j is going to start from here, and you have to just empty your this set. Okay, so now again here you are going to add 1, then j is going to move further. Okay, j reaches here, then you are going to add 2. Okay, then after that j is going to move further. Okay, and again set size it doesn't become the this size. Okay, so we don't find any complete subarray. So what you need to do now, so again you move I to the next position. Okay, then again your j is going to start from here. Okay, then again you will not find the complete subarray. Then next time again your I will start from here, then j is going to start from here. Again you are not going to find any subarray. The next time your I is going to move out of bound and you have to exit. Okay, so what was the final value of count is 4, so that's what you need to return. Okay, so now let's write the code for approach one. So it's very simple, right? Very simple, right? So what I'm going to do here, so just write the code for this using brute force. Okay, so of n square time complexity. Okay, so just maximize the size. Int n is equal to nums dot length. Okay, and here create one variable result. Okay, so here 0, and now here create one set. Okay, set, and here integer, and just name it as unique set. Unique set is equal to new hash set. Okay, now I have to iterate over all the elements in my nums array. So here you can use for each loop int num in nums, and here in the unique set you have to add the particular number. Okay, and then here you have to just calculate the size. Okay, so here you can write int total distinct is equal to unique set dot size. Okay, so this is going to be your step 1. Okay, now after that we are going to move towards the second step. Okay, so what you need to do, it's very simple. Okay, so here after it just run 2 loops. Okay, for int I is equal to 0, I is less than n, and I plus plus. Okay, so inside this you have to create one more set. Okay, so let's copy this same line. Okay, paste it here, and here let's name it as window set. Okay, window set. All right, this is done. Now after this, inside this run one more j loop. Int j is equal to, j is going to start from I. Okay, at what position my I. Okay, and j should be less than n, and j plus plus, and inside below this, so you have to write just this window set. Okay, in this you have to add the inside window set dot add, and here inside this you have to just write nums of j. Okay, now after this here just check if your window size. Okay, window set dot size. Okay, if it becomes equal to this unique set of total, okay, you can say total distinct. Okay, so here we are storing the values, right? So if it becomes equal to the total distinct, right, and then in that case you have to just update your result as result plus, and after that n minus j. Okay, so I have already explained why I'm writing n minus j. Okay, and then just break this. Okay, only exit this j loop. All right, and in the end you have to just return what, you have to just return result. Okay, so here return result. Okay, so now let's just format the code and run it, and let's see if there are any code issues. We'll try to fix that. So see, only 22 lines of code. Okay, now let's submit it. So see, our solution is accepted, right? And we are somewhere here. Okay, right, and here 255 milliseconds. Okay, it's taking, this is a runtime. Okay, and the time complexity is going to be of n square, because we are running this loop, and inside this again we are running this loop. Okay, so first time I is running. Okay, then j is also starting from here. Okay, the next time when I moves here, then j is also starting from here only. Okay, then next time when I moves here, then j is also going to start from here. Okay, complete. Okay, so that is why we are able to pass this solution because constant size is very small. Okay, so now here let's move to the approach 2, which is sliding window approach. Okay, and we are able to pass the solution with just of n time complexity. Okay, so here just do one thing, just delete this part only, and inside this we will only modify few lines of code. Okay, so first let's understand the sliding window approach. Okay, so take this same example 1 3 1 2 2 1 3 1 and here 2 and here 2. Okay, so this is your nums array, right? And these are the indexes 0 1 2 3 4. Okay, so now here inside this what you need to do. Okay, so here just take one pointer left, okay, place it here, and take one pointer right and place it here. Okay, so now right now here first same thing. Okay, step one will be same like this. Okay, so first will calculate the distinct elements, and the size is 3. Okay, total 3 distinct elements are there. Okay, so using same code we will find the total distinct. Okay, so this is going to step one, and in step 2 we are going to place my r pointer, right pointer to 0 and left pointer to 0 as well. Okay, so now here what I'm going to do, I'm going to move this right pointer, okay, forward, and I will do until the this frequency map. Okay, I will create one frequency map. Okay, and in that I will just store the size. Okay, so here what you are going to do, so here see first your r is here, so here you have to write element is 1, so one frequency is 1. Okay, this is done. Okay, you have stored the frequency. All right, okay, now after that your r is going to move further. Okay, r is going to reach here. Okay, and here we have element 3, so 3 frequency is 1. Okay, and now after that your r is going to move further. R is here, so here one frequency is going to increment to 2. Okay, one frequency is going to increment to 2. All right, done. Then after that your r is going to move further. Okay, r it is here. Okay, and here you have element 2. Okay, so 2 frequency is going to become 1. All right, so now here 2 frequency is going to become 1. Okay, then after that your r is going to move forward. Okay, your r is moving forward here. Okay, r is moving forward, and now I am checking few things from this frequency map. Okay, so I incremented this r, but now if I see here, come here. Okay, I incremented this r, but now if I see here, okay, I see that the size of this frequency map, okay, let's say this is my hash map named as frequency map. Okay, and here in this frequency map we have 3 keys, 1 3 2. Okay, so frequency map size is going to become this total district size. Okay, number of district elements. So in that case what you need to do, you have to increment the count. So here result, okay, so you are going to update the result as plus equal to the total elements in my nums array. Okay, total is 5. Okay, so n minus right plus 1. Why I am doing plus 1? Because my right moves, okay, here to this position. Okay, but until here I was able to fill this frequency map and having the size 3. Okay, so my r moves later on, so here I am adding plus 1. Okay, so here if you apply this formula, n is 5 minus r is at 4 plus 1. Okay, so 5 minus 4 1 plus 1 2. Okay, so 2 is the result, because until here there is one complete subarray, so definitely this is going to complete subarray. Okay, and here I am adding plus 1 because previously I moved my r to the next index. Okay, so that's the reason I'm adding plus 1 here. Okay, now what you need to do once this is done, okay, once this is done, then after that your result is 2. Okay, now after that you have to move. Okay, so this is done. Okay, so we have formed this. Okay, so my while loop will automatically stop. Okay, so my r is only going to move further until my right is less than n. Okay, this right is less than n, and the frequency map dot size, okay, this side is less than total distinct. Okay, okay, so here right now it is equal to total distinct. Okay, so what I'm going to do now, after this only I'm going to move my left. Okay, so now my left is going to move here. So if my left is moving here, then definitely I have to remove this element from my frequency map. Okay, so this frequency is going to become 1. Okay, right, now again if you see, all right, now I'm not going to move r forward. Why I'm not able to move the right forward? Right is less than n, this is valid. Okay, but here there is one and condition which is saying that this frequency map, okay, fm dot size, it should be less than distinct. Okay, less than distinct, but still see this frequency map is having 3 keys only, so I'm not going to move r forward, but now I'm going to update this result again. So here previous value of result was 2, and here n is 5, my r is still at 4. Okay, plus 1, so here 2 plus 2, again I will get 4. Okay, my this is updated 4. Okay, now again, okay, again what I need to do, again my l is going to move forward. Okay, so l is moving forward. Okay, so now if my l is moving forward, so here I will see that 3 frequency is going to become 0. Okay, so if 3 frequency is going to become 0, then what I'm going to do, so I'm going to remove this, okay, completely. Okay, now here if you see, I removed it, okay, because I'm removing this 3, okay. So if I removed it, now here my right can move forward, okay. So right can move forward, okay. So here right is going to go here, okay, here, okay. But no, right, it should be less than n, okay. So it is not valid, okay. So now this is not valid, okay. So right can't move forward, so again my left is going to move here, okay, and right is going to stay here only because we can't move further, okay. We can't move out of one, okay. So again L is going to reach here, okay, and side by side we are also going to reduce the frequencies, okay. 1 is going to become 0, then 2 is going to become 0, okay, and complete empty, okay. So this is what we are going to do, and in the end, so you will see that we are not going to form the any new valid frequency map dot size equal to distinct, okay. So in the end your result is going to be 4, okay. So it's very simple, right? Now let's write the code for this approach. So only few lines of things we have to add, okay. Now here create one map, okay, and here frequency map, okay. So integer, and here also integer, and here you have to write frequency map, and here you have to write new hash map, okay. This is done. All right, now after that here take one pointer int right and set it to 0, okay. And now inside this run one more loop, okay. Int left is equal to 0, okay. So here if you see I'm not moving r again starting from here, and again my r is going to be remain fixed, okay. My L is only moving one by one, okay. So if I r reaches here and next time L move here, okay, then only R is covering every element one time only, right? Okay, it is not going to restart, okay, like here I j I and j, okay. It's not restarting. So if j is fixed here, then it is only going to move forward, it is not going to come backward, okay. It's not going to cover again and again same elements, okay. So here int left is equal to 0, and left is less than n, and here left plus plus. All right, so here this is done, okay. So inside this I will check one more thing, okay. So I'm only going to shrink the window from the left, right? I'm shrinking the window from left only. So if my left is greater than 0, okay, if my left is greater than 0, only then I will shrink the window, okay. So right now in the first step I'm not going to shrink the window, okay. So here what we have to remove if we want to shrink the window, so int to remove is equal to nums of left minus 1, okay. Previous item we have to remove, okay. So if my left is moving further, right? All right, and below this code I will write the logic when my left is going to move forward, okay. So here then we have to update my frequency map, okay. So frequency map dot put, and here key is going to be to remove, all right. And here frequency map dot get here to remove, okay, this key, okay. So from this you have to just subtract 1, okay. So if you are removing that element, okay, so you have to reduce the frequency by 1 of that particular element. And if the frequency map, okay, the value, okay, of that particular key becomes 0, then we have to remove that, okay. So here if frequency map dot get, and here you have to write to remove, okay. If it becomes equal to 0, then in that case you have to just reduce, okay. So you have to just remove, okay, frequency map dot remove, okay. So if frequency reduced to 0, then we have to remove this, okay. So here remove, here you have to write to remove. This is done, okay. So this we are only going to do when my left is going to be not 0, okay. It should be greater than 0, okay. So here this is the first thing. And then we have to expand the window to the right, okay. So here I'm going to run one while loop, okay. So while my right is less than n, all right. And here frequency map dot size, okay, it should be less than total distinct, okay. Only then I am moving in my right, okay, total distinct, right. And here inside this you have to write what is the element that we are going to write, okay. To add is equal to nums of right, all right. And here again frequency map dot put, okay. Now we have to add this, okay. So here you have to write frequency map dot put here, but you are going to add this to add key, okay. But make sure that this key is already not there, okay. So here what I'm going to do, here you have to write frequency map dot get or default, okay. So it is going to check if this key is already there, okay, to add. So it is going to take the existing value, okay, of that particular key. Otherwise it is going to start from 0 and add 1 to it, okay. So it is going to add 1 always, but it is going to check if key is available, then take that value and then add 1. If key is not available, then take 0 and then add 1, okay. Done, right? Now after this you have to always move right, okay, forward, okay, REGHT, okay, right plus plus, done. All right, now this is for while loop, okay. now when we have to update our left, okay, so here left is fixed, okay, so see, in when I'm running this for loop, left is fixed, okay, 0, right? Now I am inside this, I'm expanding the window, okay, so once this while loop is done, okay, then after that here I will check one more thing, if we found a window with all the distinct elements, okay, so here if frequency map dot size is equal to total distinct, okay, total distinct, all right, so in that case now you have to update your result as result plus, okay, and here you already know why we are writing n minus right plus 1, okay, because here if you see we incremented right here, okay, after that, so that's why I am writing plus 1 here, okay, right, moving first to the next index, then we are checking the size of frequency map, okay, so that's the reason I'm adding plus 1, okay, so all subarrays starting at left and ending from the right to n minus 1, all right, so now in the end you have to just return the result, okay, so now let's just format the code and let's run it and see if there are code issues. So see, all the test cases has been passed. Now let's submit it. So see, our solution is accepted, right? And now we are here, okay? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye-bye.